Welcome, I'm Professor Stan Johnson. The following presentation is for our class, Business Project Risk Management. This presentation is on Chapter 14, Using Outputs of Monte Carlo Analysis in Decision Making. The specific objectives of this chapter include 1. Define the deterministic uncertainty management approach. Number 2, explain the probabilistic uncertainty assessment approach. Number 3, illustrate the main templates used for preparing input data to probabilistic modes. Illustrate a project-based estimate and project duration. Explain project risk management system. And then finally, to illustrate risk breakdown structure. This slide looks at the anatomy of output distribution. The risk management plan should define criteria, which is confidence levels, for project reserve and additional management reserve. This is for both cost and schedule analysis. Now this slide shows the comparison of two projects. A good way to look at the two and have a clear idea of the strengths and weaknesses of the two is by looking at this type of charts. You can see how this helps to make a more informed choice. Project A with higher estimate but narrow spread of overall cost uncertainty is preferable between the two. Projects A and B could refer to the same project before addressing Project B and after addressing Project A, where the difference in the estimates A and B is equal to the cost of addressing. How to increase the confidence level. We begin by accepting all uncertainties as is and putting away required reserve. Number 2, we do an optimization of the baseline. And then finally, number 3, we're addressing the uncertainties and accepting residual ones, which would be the 2B. This is a list of possible reserve criteria. This is just an example of a list that could be used. Number 1, it should be stated which uncertainty objects are covered by the total reserve. Number 2, some organizations use project reserve released to a project team and management reserve not released to a project team. Number 3, some organizations use one total project reserve. Number 4, some organizations are flexible and apply criteria depending on competitive situations, which is confidence levels between 20 and P50, presence of competition. Then confidence levels of P50 to P95 where competition is not important. Number 5, some organizations always use the same criteria, using project owners such as the mean, P70, P90, etc. This is sometimes done just to add to consistency, and it's easier to look at previous projects and measure them against one another. Some organizations use internal and external criteria, where external ones are used in the RFP processes and as stretch targets for a project team, which is similar to the split of project and management reserves. It is always a good idea to be pushing these stretch targets and getting your teams to become more productive as they are doing continuous learning from previous benchmark projects that have been performed by the organization. The risk reserve criteria should comply with contractual requirements, and it should not be too prudent to ensure competitiveness and financial efficiency. Okay, so it should not be on the opposite extreme, too aggressive, to avoid uncovered uncertainty exposure. This next slide shows the optimal risk management curve. Having hefty risk reserve and losing a bid versus one that is having lean risk reserve, winning the bid, and then lacking funds to cover the uncertainty exposure. We already talked a little bit about efficiency and the 3 E's, and you can see how that is affecting this. You want to have that optimality, like Pareto optimality. You want to find that optimal place in this chart and know exactly where you want to be. And these types of charts help to represent it in a way that's easier to look at and understand than just numbers on a page. Let's answer the question, are AACE accuracy classes accurate? The answer is no. Any estimate could be assigned a variety of accuracy range, making the resulting highly subjective bias evaluation. Okay, to exclude the dichotomy related to ambiguity of accuracy range definitions, models are used to define true or primary accuracy ranges. This chart shows the definition of primary accuracy ranges. You can easily see that on the left, P5 is a minus 3.1%, while on the right side of the chart, P95 is a plus 17.6%. This gives a reasonable project reserve of plus 11.1% at P80, with a reasonable risk confidence level of P80. The primary accuracy ranges are not declared, they are calculated, okay? And the basis for the calculation is using P5 and P95 levels of confidence. You can see anything below that and anything above that would be kind of unreasonable, and it would be a waste of money. This chart shows a comparison of the ACCE classes versus primary accuracy ranges. You can see the classes on the left with P5 accuracy from P0 to P10, while P95 range for primary accuracy is from P90 to P100. A comparison of these ACCE classes with primary accuracy ranges is not mandatory. However, it could be used in order to unite the worlds of estimating and risk management. Okay, let's talk a little bit about reserve drawdown. What this is drawing down the funds prior to the end of the project. In the course of project development and uncertainty addressing, an initial final investment, which is decision, which is the FID, baseline cost reserve could be partially released. So you could release some of the funds. It could be done on a regular basis, either monthly or quarterly, and then the drawdown forecast could be done for any future moment in time. Required reserves could be also evaluated for future dates using existing Monte Carlo models as assessments of 2B1 and 2B2, and then you could evaluate different scenarios that way. This slide talks a little bit about the sensitivity analysis that is a part of making your choices. I think this is what really gives a very strong ability. It's like a priority for your um, assessment of risk analysis. This way, you'll end up attacking the more sensitive areas that are actually going to affect um, the baseline or other components or your critical path. Number one, upon completion of cost or schedule assessment as is, it is important to understand which baseline components or normal activities or cost accounts, general uncertainties, and uncertain events should be further addressed to reduce overall project uncertainty. And this sensitivity analysis is the primary method to generate such leads. Okay, this sensitivity analysis ranks general uncertainties and uncertain events, and this is in the tornado charts. Okay, that we've kind of looked at some of those. The higher an uncertainty rank, the higher the sensitivity of the overall project cost or schedule uncertainty related to the primary uncertainty, which is what I'm already mentioning. You know, your impact on cost and schedule are going to be higher there. Addressing the most sensitive uncertainties is the most efficient method to reduce overall project uncertainty, which is our goal. Okay, there's 4 charts here that show different types of schedule sensitivity analysis. So you can look at these, and by looking at the graphic representation, get a good picture as to what is occurring. On the top left, only general uncertainties are looked at here. This is all that is represented in that chart. Okay, and the top right, we're representing only uncertain events. The upside uncertainties are going to be shown here as negative, in a negative manner, okay, because they're positive, and the chart is really aligned to show the uncertain events that are something that you're going to have to deal with, and not the positive events. But you need to have that objective look at what you've got and factor in both the positive and the negative events. This tornado chart comes from chapter 16 from Project Curiosity also. The bottom left is the general uncertainties and uncertain events. And the bottom right is the critical index factor, how often an uncertainty belongs to the critical path in iterations. This chart provides an example of cost sensitivity analysis. 3 schedule direct costs related to schedule delays are shown here on the chart as general cost uncertainties. Now, the running of what-if scenarios is an advanced sensitivity analysis. The standard sensitivity analysis is based on the ranking of the particular standalone uncertainties. The main thing we need to get out of this is what-if analysis is often the most valuable project risk management activity, and the decision maker should be very proactive in formulating what if scenarios of interest to be able to kind of look at it ahead of time. What if this happens? What if that happens? Your student assignment is to write a reflection paper, then send it to me, Dr. Stan Johnson. My email is profstan@gmail.com, and then put chapter 14 makeup in the subject. Thanks for your polite attention. This concludes today's presentation.